Welcome to Technovation. I'm your host, Peter High. My guest today is Huma Abidi. Huma is the General Manager and Senior Director of Artificial Intelligence Software Products and Engineering at Intel. She's responsible for strategy, requirements, validation, benchmarking, and customer support for deep learning, machine learning, and analytics software products. She leads a globally diverse team of engineers and technologists responsible for delivering AI software products and customer solutions incremental in Intel's multi-billion-dollar AI revenue growth. She's a two-time recipient of Intel's highest honor, the Intel Achievement Award, and a three-time recipient of the Intel Software Quality Award for delivering quality software. She's a champion of women in technology and DE&I initiatives, and whom was named as an honoree for 2021 Tribute to Women Award by Silicon Valley YWCA, and recognized as a Women of Influence in 2021 by Silicon Valley Business Journal. She's the founder of Women in Machine Learning at Intel as well. I look forward to covering all of the above and more with her. Huma, welcome. It's great to speak with you today.
Thank you, Peter. I'm really happy to be here.
Excellent, as am I. Huma, maybe we begin with your role, if you don't mind. I mentioned a moment ago, you are the General Manager and Senior Director of Artificial Intelligence Software Products and Engineering at Intel. Take a moment, if you would, and just describe that a little bit more as to what that entails and your areas of responsibility, please.
Absolutely. So as you mentioned, I lead a worldwide team of engineers who are responsible for delivering end-to-end AI software solutions. And this means that they are optimized to achieve peak performance across a variety of hardware architecture. We work with popular open source product ecosystem like TensorFlow. We're working with Google or PyTorch with Facebook and MXNet, Amazon. So we work with the popular open source product ecosystem products. And more importantly, we want to make sure that we meet all our customer needs, meaning that our AI software is easy to use. We're focusing on simplicity, productivity gains, the software is performant, it's unified. So if you want to deploy AI software today, it's not very straightforward. You have to find the right solution, the right software, you have to find the right model, right data set, and all these things require skill set, training, people who understand AI. And our goal is to make sure that it's easy to use for different types of persona, different types of customer. So we want to make sure that software solutions are low code or no code, meaning very easy to use. It's like a turnkey, easy to use containers, or we create vertical toolkits, reference tools. Again, the focus being that it's performant and it's productive and it's out of box. That's the goal, that we want to give our customers a very good out of box experience. And that's my primary goal in this role.
That's a great overview, Huma. Thank you so much. You mentioned artificial intelligence software several times here, and everyone who would be listening to this is certainly familiar with software, generally speaking. As Mark Andreessen claimed, it's eating the world. Talk a little bit about some of the differences between software, typical software, and artificial intelligence software. I'd love to understand some of the nuances there, given your area of expertise that you just noted.
That's a great question, Peter. So before I even talk about software, let me talk about AI hardware. So the increasing diversity of AI workload has pretty much imposed a demand for different types of AI optimized hardware architecture. And then I'll talk about the software. So when we talk about AI hardware, it can be divided into three main categories. So you have CPU, the general purpose CPU. You can actually run AI workload there. And in fact, our Xeon processor have AI accelerators built into that. Then you have your GPU, and then lastly, it's a purpose-built dedicated hardware accelerators. So while AI hardware has continued to take tremendous strides, the growth rate of AI model complexity is actually outstripping those hardware advancements. I'll give you an example. Like 3 years ago, a natural language AI model, Elmo, had we call it now just 94 million parameters. Whereas now the large models have exceeded 1 trillion parameters. So the point is, this exponential growth of AI means that even if like 1000x increase in computing performance, it can easily be consumed by the ever more complex AI workloads. So that's where the software comes in. then to solve these complex problems, it's possible through the orders of magnitude performance enhancements that are driven by software, what we call it AI accelerators. And by that, I mean that AI performance improvements that can be achieved through software optimizations for the same hardware. So we have seen over and over again that our AI software accelerators can make 10 to 100x faster. They can make platforms up to 100x or sometimes even more faster across a variety of applications, models, and use cases. So that, plus, as I mentioned earlier, that the goal that I have is to make it easy for people to use. The second point I would love to make is what you asked, like, what is an AI software? And actually, it's different because you can think of it as segmented into 3 layers. The top layer is the application layer, where majority of the time that application developer, that's where they do their day-to-day work. This is where, for example, if they're looking for an anomaly in an X-ray, or movie recommendation, or in my case, I love to paint, and then I try to blend my paintings with the neural style transfer technique. So all those things that at an application level, that's the top layer. Then there is the middle layer, and the middleware layer where we have AI frameworks, which is a collection of building blocks and libraries. This is where your data scientists and ML engineers will create, train, validate, deploy their AI model. And this can be deep learning or machine learning. I mentioned earlier TensorFlow, PyTorch, XGBoost, and some libraries, NumPy. So this is where the data scientists and ML engineers will work. And the lowest layer of the software stack is the one that is closest to the hardware. And this is where it will interact with the layer above, as well as the hardware that it's being targeted for. And this is often written by library developers. So these library developers would need to have the expertise of hardware software co-design, that how hardware and software interacts. So the point is that it's not just one thing. As you can see, there are different people use different kind of engineers using it, different expertise is needed for each of these layers. And that is overall what makes an AI software.
That's a great overview. I really appreciate it. And I want to return to a point you made in the throes of your response. You talked about how you personally leverage artificial intelligence in the art that you create. First and foremost, the fact that you create art is a fascinating tidbit about yourself. But I love that you're taking a personal interest and blending it with an area of expertise from your work as well. And frankly, the cross section of that will no doubt be esoteric to some of the people that are listening and watching this. So I wonder if you could take a moment. We've been hearing a lot about the connection points of AI and writing articles or writing poetry or writing music. I'd love for you to take a moment and talk about your own experience in terms of the cross section between AI and art. And if I may suggest a follow up to that, how bringing that into your personal life impacts the way in which you think about it in your work life.
I love this question, Peter. I love to talk about that. So we work with customers in pretty much every domain. So there's healthcare, agriculture, education, security, telecom. There's always something or the other. And I love that about my job, right? It's not just one area because AI is everywhere, right? But there is this I probably less attention paid to the creativity, that the intersection of AI and creativity. So this is something like maybe 3-4 years ago. So I love to paint, and I like to do embroidery and painting and lots of different things. That's my thing that I do outside of work. And so I use this optimization technique called neural style transfer. And what that does, it takes 2 images. So it's a content image, like one of my paintings, and a style reference image. Now, the style reference image could be style of a famous artist like Monet or Van Gogh or whoever, or an object. Like oftentimes, to demonstrate something, I would take a picture of an Intel chip and then blend them together, and the output image looks like the content image, but it's painted in the style of the reference image. So it is like amazing how much time I could spend hours doing that, because every time it's something different. And so the results are outstanding, and there's a lot of interest in that. And I've done a lot of work with my paintings, and I've used it for different purposes, and this has really helped me to look at it in a very different way. So that's one. But I want to touch upon what you said, that now AI is being used to create poetry, podcast even. I mean, obviously nothing as close to your podcast or Technovation, but there are podcasts that are. Well, there's one called Rubra, and that is like completely scripted and spoken by artificial intelligence systems. And they basically collect interesting news, play computer generated music, and it just is out there. Music. Oh, there's another podcast that I heard about recently, which is called Deep Dreams, and that is using the GPT-3 language transformer, and it generates this music or stories actually that can lull you to sleep. So there's all of those things happening, and music, you mentioned, like it can create music in 15 different styles. It can imitate classical composers like Mozart, but also contemporary artists like Lady Gaga and different instruments. So it's just amazing how many interesting things are happening. And I mentioned GPT-3 in the case of Deep Dreams. So GPT-3 is so amazing that it can generate any type of text, like take a small input text and to really sophisticated machine generated text. And just last week, my son was having a discussion with a cousin of mine who is a professor. And my son was saying that you have your students write essay. What if they use GPT-3 to create essay? And my cousin was like, oh, but I can check to make sure that there are tools to check plagiarism. And my son was saying, there is no plagiarism here, because you give this, even if you give the same input, and he was actually demonstrating it, if you give the same input, the content will be different each time. So it's become so sophisticated that no matter what little input you give, you can write blogs, you can write essays. It's getting better and better and better. And something that's called DALL-E 2, again, same by OpenAI, and that has amazed me so much, because what it does is it creates realistic images and realistic images and art from a description. And it's not that it just goes and finds an image, it actually creates it. So you could say that, maybe an octopus wearing a dress on a moon, it will create an outstanding image. It's just so amazing that how much it has evolved, how much better it has become. And I'm actually trying to get into the beta program so I can play with that, because there is this art, there is this AI, and this is the part of AI which is not very discussed, at least not at my job, but I love to see that. And there are many students and high school students that I mentor, or even college students, and they have the AI has this is very interdisciplinary. So when I talk about this, they're very fascinated. How can you apply AI to art? And there's so much going on that makes me so excited. I'll stop here because I can go on and on about this.
Great anecdotes all. I really appreciate that, Huma. And I wonder to what extent, so much of what you're describing, of course, is AI synthesizing great works, for example, or very personalized styles, as you point out, your own personal art, for example. And it strikes me a lot of what you're describing is, in some ways, the fusing together of what humans do well and what AI does well, the partnership, if you will, between those two. And do you foresee, to what degree do you foresee AI surpassing, from a creativity perspective, human capabilities? It still strikes me as it's a synthesis of great works of humans. To what extent does this get to the point of, and how quickly, from your perspective, of surpassing our abilities in one way, shape, or form?
That's actually a very good question and often asked. And the answer is, at least to me, if it's not hundreds years, at least decades away where it can, because there's all these things happening, but they're happening in the specific area. And if you talk about general artificial intelligence, that's really, really far away. So what AI is getting better and better is specific tasks that you give it. And so the thing that worries me a lot about AI is the bias, the limitations of AI. And in that specific example of DALL-E 2, actually, that when you create images, there have to be checks and balances, right? So in the case of DALL-E 2, if you want to create something which is offensive, or if you want to create someone popular or famous saying something that they shouldn't say, there are checks and balances that are being put in place. And so this was a big worry that people had, that AI can do anything, and that is something where we should worry about right now. So if it's surpassing human, that's going to take a long time. So if you want, I can talk about the biases in AI and what we are doing to overcome that.
Please do, Huma. Clearly, a big topic that many people have talked about. That if there's only a certain kind of person who's working on artificial intelligence, naturally the algorithms behind that will be reflective of the taste and experience, perhaps, of the developer. And so, to take only, I'm scratching the surface in terms of some of the issues associated with that. But talk a bit about what you are seeing in terms of, and maybe define the issues associated with bias a little bit more. And if you could also, what sorts of things you and others, or what you're seeing being done to rectify that.
Absolutely. This is equally important, right? So as you know, AI is pervasive in our daily lives, and now it's being used from everything from recruiting decisions to healthcare risk prediction to judicial sentencing, approval of loans, and of course, movie recommendation or Spotify. So if a movie recommendation is flawed, that's nothing. It's not the end of the world. But in the other case that I just mentioned, if there is a data or an algorithmic bias, the result could be disastrous for those who are at the receiving end of this decision. So despite the great intention of the technology that are building, it should be serving all. If the people or the group who are creating this technology is homogeneous, and that this is something also that I will hopefully touch upon, is how diversity is needed. It will work for that specific population, and that innate or unconscious bias will show up in the decisions in designing the algorithm. So there is incomplete, underrepresented bias data or algorithmic biases that I mentioned earlier. This can really lead to unintended consequences. And so these are the types of challenges that we need to fix for AI to move forward and to be successful. And so, for example, the deep learning models that they're using is like a black box. For example, if a loan is denied, what is the reason it was denied, right? We need to know that. And right now we don't. So a lot of focus these days is in the area of responsible AI, explainable AI. In fact, Cynthia Rudin from Duke University, she received a Squirrel Award equivalent of Nobel Prize for computer science for the work that she's doing in this area. So that's how much important this area is. And, like everybody else, my team and I are also working on expanding our focus into integrating fairness, explainability into our AI software. So, for example, if we publish any model, we want to make sure that it goes through a checklist of, say, data sheets for data set, which has information about where this data is coming from, how comprehensive it is. Does it represent all? How is it updated? Similarly, for models, we have a model card, which will say that all the information is relevant for the intended application domains. Then we are using this very popular SHAP tool, which basically identifies which features are important. And this is towards the explainability that this decision was made because of using this feature. If we instead started using this, how would it be? So there's a lot of work that we are doing. It's far from completed, but the fact that everybody's realizing this is an issue, that by itself is something great.
I want to thank you for that overview. It's fascinating to see and hear about the work that's being done to counter some of these issues. And I want to go back to a topic you briefly noted, that of diversity. I can only imagine that when you were getting your master's in computer science, for example, you were not surrounded by women in the courses that you were a part of. And likewise, in your rise in your technology career, I'd imagine that there were more men surrounding you than women as well. You are representative of progress certainly being made as you've reached higher heights, hopefully inspiring others to walk in your footsteps. But I wonder if you could take a moment as somebody who's been a champion of this, clearly values diversity, including gender, among other sorts of diversity that are necessary, to talk a bit about the progress made and the progress yet to be made, please.
Another favorite topic for me, Peter. Thank you for asking. So I've pretty much spent most of my career advocating for women, advancements, education, and getting them into STEM and AI. And it is a priority for me to get more and more women in STEM and computer science, and then coaching and mentoring women at Intel, outside. I am involved in various different such initiatives across the globe, actually. And as you mentioned, I'm founder of Women in Machine Learning at Intel. And then I also work with women in big data, Girl Geek, advisor and led by. So those are the things that I'm doing from my part, because I think that diverse group will build better products for a diverse population. And especially, as I mentioned earlier, that it's important for women and underrepresented minority to be part of AI, because of the potential bias lack of representation can cause when creating AI solutions. So in AI, it's especially more and more important. The second part that you asked, that in order to attract women, we need to do a better job explaining to girls and young women how AI is relevant in the world and how they can be part of creating something exciting and impactful solution. I also mentioned that AI is extremely interdisciplinary, so they can actually apply AI to almost any domain that they are part of. And so that's one way of looking at it, that AI spans so many different areas of life. Like you can use AI technology in their domain of interest, whether it's art, as I mentioned, or robotics, or journalism, or television, or whichever they're doing. The other important part also that you mentioned was that representation is very important. That for women to see role models and to see that there are other women who are doing that. And fortunately, there are many wonderful women leaders who can serve as excellent role models. For example, Fei Li, who's leading human-centered AI at Stanford. Meredith Whitaker, who is working on social implications through AI Now Institute at NYU. So there are, many such women and as well as men who are encouraging more and more young girls and women to be part of STEM and especially in AI.
Well, Huma Abidi, thank you so much for joining me today, sharing a number of topics of great passion of yours, the areas that where your personal interests and your professional interests overlap. It's been a wonderful conversation to learn more about your journey, and I appreciate you sharing it with me today.
Thank you so much, Peter. I'm really happy to be here. Appreciate you inviting me.